Data centers, they are absolutely everywhere. They're big, they're complex, they're full of different switching and routing adjacencies and protocols. And configuring a data center, configuring the network in a data center shouldn't be complex. It shouldn't give you a headache. And in this video, in 8 easy steps, I'm going to show you how to configure a spine leaf topology using EVPN and VXLAN. Hey everybody, and welcome back. I'm David Townsend from the Net Academy, where we are learning networks together. And on this video, what we are going to go through, what we are going to see and do is how to configure a spine leaf topology that you get in data centers using EVPN signaling, or Ethernet Virtual Private Network, and VXLAN, or Virtual Extensible Local Area Network tunneling. Those are two big protocols in one. They're not the same, but EVPN is particularly very big. It's a mammoth protocol because it's really a protocol that sits within multi-protocol BGP or MPBGP. I'm going crazy on the acronyms already, but I'm going to go through this. I'm going to show you, we're going to go through in the lab how to do this in 8 steps, from initially configuring the router ID and all the way to actually validating at the end, is this EVPN, is this VXLAN tunneling actually working? Obviously that's very important. But if you do not know what EVPN is, if you do not know what VXLAN is, stop right now. Don't go any further, because everything I'm about to do you are not going to understand. Here's a video that I've done on the EVPN basics, the basics of VXLAN as well. Highly recommend you start there. Also, this is going to be a bit more of a heavier session. It's going to be a bit of a more technical video. So please have your coffees ready. I'm going to be taking a coffee now and then. You're not going to see it, and we'll get through this together. But for now, let's go straight onto the lab and let's get going. And here is the network that we're going to be using for this video. Now, most of this you need to be aware of. You need to be aware of the different hosts and their IP addresses and the VLANs and the VNIs that they're mapping to. But let's take it one step at a time. What you don't need to be aware of really and remember by any means is the IP addressing you're getting on all these interfaces. Honestly, that's just there for my own benefit, for me to do the check-in and the connectivity testing. So you don't really need to be aware of that. But what you do need to be aware of is in the previous part, the previous video that I'd done in this EVPN VXLAN series, we had a spine leaf topology where there was a connection running between the spines themselves, and we had the EVPN and VXLAN tunneling going over this link from spine 1 to spine 2. And this was okay, wasn't it? It was okay from a topology perspective, but it wasn't the best. It wasn't really getting all the many benefits of EVPN. If you don't know what the benefits are, please check out this link, another video that I've done. But when we had that spine only topology, from the leaves all the way up to the spines, everything was still layer 2. So we had to have our layer 2 trunking absolutely everywhere. So we had to trunk on this interface here, we had to trunk on this interface here, there. You get the point. And we only had layer 3 really running between the spines themselves over that connection where there was EVPN and VXLAN, as I said. But going back to the layer 2, we then had to configure the Ethernet segment identifiers, or ESI, on those spine devices. We had to configure the aggregated Ethernet bundles, tongue twister, on the leaf devices. And because we only had layer 3 between the spines, we weren't really fully utilizing all those many benefits that you get with EVPN. If you don't know what spine only is and the configuration, please check this out. But when it comes to a spine leaf topology, we have from the spine all the way down to the leaves, we have layer 3 absolutely everywhere. It's only really from these access interfaces down that we then have the layer 2 to give access to these hosts, these servers, these virtual machines in their different VLANs or in the same VLANs, connectivity to the network. And because we've got layer 3 from the leaf devices all the way up to the spine devices, we get all the benefits, because it's layer 3, of EVPN, of VXLAN, and we don't have to trunk, we don't have to create aggregated Ethernet interfaces, we don't have to configure ESIs and maybe worry about spanning tree protocol as well. And also because of that, you can see there is no connection between the spines, it's simply not there. So even though we are doing a spine leaf topology where we are going to have that layer 3 interface, that IRB interface on leaf 3, on leaf 2, and all the way over here on leaf 1 as well, we are getting all the many benefits of EVPN, where we've got that distributed gateway, that Anycast gateway, as close to the source of that traffic as possible. And that's important because if we look at host 1 here, if this is a virtual machine in a data center, as we know, virtual machines, they could be migrated. This server, this virtual machine on this server could be migrated from this server here over onto this server here. It can move from leaf 1 over to leaf 2. And having that same gateway with that same IP address, that virtual IP address, and that same virtual MAC address allows that tenant, that virtual machine, to migrate and still maintain connectivity. And because we've got that layer 3 gateway all the way as close to the server as possible, i.e. on the leaf devices, then gives us more capability to actually distribute that workload throughout the network. But what you can also see here is the root reflectors. So the spines are going to be configured as root reflectors. This is very different to what we've done in the spine only topology, but I don't want to say too much too soon, but just note the spines are going to be configured as root reflectors, and that's important. But what are these 8 steps that I actually mentioned? Well, step number 1, the routing options. You could see here for every spine, for every leaf, there is a router ID. So leaf 3 here has got this router ID, leaf 2 here has got this router ID, spine 1's got this router ID, so on and so forth. We need to configure the router ID for all of these spine/leaf devices for them to identify who they transmitting and receiving packets to and from respectively. But you can also see there's values here such as the autonomous system number, or ASNs. So the ASN needs to be configured in those routing options as well. So that's step number 1. Very quick, very easy, not much to actually do, but if you forget them, then that's going to cause you quite a few issues later on in the next steps. But step 1 is the routing options. What is step 2? Step 2 is configuring the underlay. To get all the way up to EVPN, we have to have in this network here, and don't forget this is all layer 3, we need the underlay. We got to have an underlay routing protocol, i.e. some form of IGP, interior gateway protocol, to provide that initial connectivity on the underlay. And we're going to take the loopback addressing, the loopback 0.0 that's configured on all the spines and all the leaves, and we're going to distribute that into the IGP. And that's very important for the 3rd step. So the IGP protocol we're actually going to be using, and it is my favorite, I'm a bit biased to be honest, but I absolutely love OSPF, Open Shortest Path First Routing. Using the Dijkstra algorithm, calculating the shortest path in this topology is pretty straightforward, but I just love this protocol. It's an open standard, all vendors support it, it's been around for a long time, and it's still used widely in lots of different networks today. But for step 2, we are defining what is that underlay. We need to configure that IGP OSPF to provide that initial connectivity and to have these loopback addresses advertised into the underlay. Now, a quick point is that you do not want to configure interface all on the OSPF. So you can see here for leaf 1, just for example, it's only got 2 interfaces, GigE000 and GigE001, and a 3rd one of course is its loopback 0. So only 3 interfaces, but if you do configure interface all within the OSPF routing protocol, it's then going to take all active up interfaces and advertise that into OSPF. And that's going to cause quite a few issues. So we need to be specific, explicit, and configure the exact interfaces we want to advertise into OSPF to build that underlay itself. Step number 3, the third step in this 8-step process, is we've got to build the overlay. We've built the underlay in step 2 using OSPF, and now we need to configure the overlay. Now you can have different types, keyword there, you can have different types of overlay routing, but for this video what I'm going to use is IBGP, or Internal Border Gateway Protocol. And you probably already figured that out because I've mentioned already we have route reflectors here. You're only going to have a route reflector in a internal autonomous system inside that same ASN. And you can also see each spine and each leaf, they are all in the same autonomous system number of ASN 65100. So we're using IBGP. And if that loopback 0 has been advertised from all these leaves and all those spines into the underlay routing protocol in step 2 into OSPF, then IBGP should then have the peering. But we're only going to build the peering from the spines, from the leaves up to the spine. So leaf 1's going to build a adjacency to spine 1 and across to spine 2. Leaf 2 is going to build an adjacency to spine 1 and spine 2. And guess what? Leaf 3 is going to build an adjacency from or to spine 1 and spine 2. And because spine 1 and spine 2 are configured as these route reflectors, or RRs as I abbreviate them to for obvious reasons, they're then going to reflect received routes down to the other leaves. So let's put this into a working example. We've got host 1 here. It sends packets into leaf 1. Leaf 1 learns its MAC address, learns its IP address, and that destination packet is on the same VLAN for host 2 over here on leaf 2 here. Now, using the multipath function, and that's something we do need to configure as well in step 3, is we've got to configure, cannot forget it, multipath, because we've got multiple paths to spine 1 and spine 2 to get to that same destination, i.e. leaf 2, multipath, is say that leaf 1 sends the packets onto spine 1, you just choose spine 1, and at this point here spine 1 is going to reflect that learned MAC address that's been learned via route type 2 down to leaf 2, but also across over to leaf 3. It's a route reflector, it's just learning and reflecting those network prefixes, as network layer reachability information, those NLRIs that have been learned. It's just reflecting routes. Now you can use EBGP as the overlay, but if we used EBGP we couldn't then use route reflectors. And if you had EBGP, you then also need to take into account routing policies as well. So routes received, you've then got to have a policy to say, yep, all these routes received, I then want to advertise that onto this set of neighbors. So it then becomes a little bit more complicated. So in summary, this third step, we are configuring the overlay. We're going to configure IBGP. What is the fourth step? The fourth step is where we actually configure the VLANs themselves. Now, in the spine only topology, we had to configure the VLANs on the spines, but we don't need to do that in a spine leaf topology because, again, everything here is layer 3. VLANs are layer 2, and thus we only need to do so on the leaf devices themselves. So we're going to create the VLANs on the leaves, got that wrong there, and we're going to create and assign these access interfaces on these different leaf devices. I should change the pen color. There we go. Let me do that again. So these access interfaces, hey, that's better. You can now see where I'm drawing. We are going to configure those interfaces to be access interfaces and associate them to either VLAN 20 or to VLAN 10 up here. But then we also need to create those VNIs, those virtual network identifiers. And we do at this point map that VLAN onto that VXLAN VNI. So that is what we're going to be doing in this fourth step. The fifth step is that distributed gateway, or you could also call it the Anycast gateway, because as the name implies, it's anywhere. It's an Anycast gateway, and because we have layer 3 running between the cores, the spine devices and the leaves, you could have the IRBs, those gateways, on the spine devices, or you could have them down on the leaf devices themselves. There are pros and cons to each one of these. In this video, we're going to be configuring the leaf devices to have those IRB interfaces, to have that Anycast gateway. Now, specifically in this step, in this 5th step, we are going to configure the IRB interfaces. So we're going to configure IRB 10 for VLAN 10, and we're also going to configure IRB.20 for VLAN 20. IRB stands for Integrated Routing and Bridging Interface. It's a logical interface, and we then assign these to the VLANs themselves. And because those VLANs are mapped to a VNI, any traffic that comes into that VLAN is then going to have a layer 3 interface, either IRB20 or IRB10. And if it needs to go out of this layer 2 domain, that's from the leaves down, the IRB interface is going to allow that functionality, and then will, in later stages, tunnel that traffic through that VXLAN tunnel. What is the 6th stage? The 6th stage is configuring EVPN, Ethernet Virtual Private Network. So we have to configure EVPN on leaf 3, on leaf 2, on leaf 1. We don't really need to do that on the spine devices because they're just reflecting routes. And the leaf devices, they're not building adjacencies to and from each other. They're actually building adjacencies to the spine devices, as I mentioned earlier. But we've got to define the EVPN protocol. We have to define that it is going to be signaling within the IBGP. And because in the 6th stage we've configured EVPN, the protocol itself, the 7th stage is where we're then going to configure VXLAN. And that's important because when leaf 1 and leaf 2 and leaf 3 have learned that they've got all these hosts connected to them, and maybe they're moving or not, obviously in this lab they're not going to be moving, this is just EVNG at the end of the day, but these leaves will then build a tunnel to and from each other. This is my artistic skills for a tunnel, by the way. And leaf 1 will also build a tunnel over to leaf 3. And actually, that's not too bad. So any packets that need to go from host 1 to host 2, or host 1 to host 3, or host 1 to host 4, etc., etc., they're just going to be routed over those tunnels. But we have to tell VXLAN what VNIs you want to allow to be routed. What is that list of VNIs that you want to encapsulate? And this is the 7th step, is configuring that VXLAN tunneling itself. In the last step, step 7, we configured EVPN specifically to advertise and allow transmitted and received packets over that overlay. Now, in this 7th step, we're configuring the VXLAN tunneling. So when remote host MAC addresses and maybe IP addresses and ESIs or Ethernet segment identifiers have been learned, we can now build the tunnels to and from those VTAPs to get that information, those packets from that source to that destination. And the 8th step, the last and final step, is validation. It's checking that what we've done, what we are going to do, actually works at the end of the day. And the goal here is to ensure that host 1 can ping host 2. If it can, great. We know there's round trip connectivity because it's going to get a response back. But also need to test, do we have inter-VNI routing? Because host 1 and host 2 are in the same VLAN. Yes, on different leaves, but we don't have to worry about that because of the VNI mapping. But what if host 1 wanted to communicate to either host 3 or host 4? Is there that inter-VNI routing? And this is where we then, in this 8th and final step, configure or ping, can host 1 ping host 3 and can it ping host 4? Is there that round trip connectivity regardless of what spine those pings are actually going through, what route reflectors are reflecting those pings? So those are the 8 steps. So just to recap, step 1, routing options. ASNs, loopback addressing, and also router IDs. Step 2, we're going to configure the underlay. We're going to configure OSPF to give that initial connectivity. Step 3, we're going to then configure the overlay. We're going to configure IBGP on the leaves and on the spines, but additionally we're going to configure the spines to be root reflectors. Step 4, we're going to configure the VLANs and map them to VNIs, and on those leaf devices assign those access interfaces as an access interface to be layer 2 and to have those VLANs mapped and tagged onto those access interfaces. On step 5, the Anycast or distributed gateway. Again, these are going to be configured on the leaf devices, and we're then going to assign those IRB interfaces, IRB10 and IRB20, to VLAN 10 and VLAN 20 respectively, to give them that layer 3 interface and thus allow inter VNI and inter VLAN routing. Step 6, EVPN, Ethernet Virtual Private Network. We have to configure in the EVPN world what do we want to encapsulate. Step 7, VXLAN. Have to configure the VNI list in the VXLAN protocol and basically say it's okay to tunnel this traffic to and from these different VTEPs. You'll see this as we go through those steps. And the 8th and final step, validation, ensuring that everything is pinging and connectivity is there. So no more said, let's now go straight into step 1, very easy step, and configure those routing options. So here we go, let's go with the first step, configuring those routing options. Now specifically when it comes to the routing options, what I'm actually referring to is for each leaf and for each spine device we need to configure the router ID. Obviously that's going to be different for every device. However, what is going to be the same for every device is this autonomous system, is that ASN. They're all going to have this ASN, this autonomous system number of 65100. So we need to configure those two attributes for leaf 1, leaf 2, leaf 3, and spine 1 and spine 2. I know this sounds simple, and it is simple, but if you forget to configure the router ID, if you forget to configure the autonomous system, then you're going to fail to build the underlay. You're going to fail to build the overlay, the IBGP peering, that neighborship, and thus EVPN and VXLAN tunneling is not going to work. So let's just get this done out of the way, quick, easy, nothing more. And here's the command line interface for spine 1. I'm just going to highlight those attributes. So let's go into the command line interface and into configure mode, and let's do edit routing options. Now if you know Junos, you know the command to set. There's the hint. Set a command is set. It was a bit of a big hint that I actually gave. But first we need to do that router ID of 1.1.1.1 for spine 1. Now also then need to define the autonomous system number of 65100 for spine 1. That's it. That is literally what we're going to do for each one of these devices. But now I'm just going to do a commit with a comment, and I'm just going to call this routing options. And there we go. Spine 1 is done. I'm just going to actually copy this command. So I'm just going to do here. And let's go on to spine 2. I will again highlight those attributes that we need to configure. But let's go into command line interface, do configure, and let's do set routing options router ID 1.1.1.2 and set the autonomous system number 65100, and then let's commit that with the comment of routing options. Spine 2 done. Let's go into leaf 1. Let's go into command line interface, configure mode, set routing options router ID 1.1.1.3, set routing options autonomous system, spell it right, 65100. Commit that with the same comment. And on leaf 2, let's go into the command line interface, configure mode, set routing options router ID 1.1.1.4, set routing options autonomous system 65100. Commit that with the same comment. And now let's move on to leaf 3, command line interface, go into configure mode, set routing options router ID 1.1.1.5, and it's set the routing options for the autonomous system for BGP 65100. Commit to that with the comment. And that's it. That is step one, literally done. But those are so important. Do not forget them. This is just my logical way, my quick and easy way of getting this EVPN and VXLAN network up and running. Start off with the basics, configure the routing options, and just build up from there. But now let's move on to step two. So now we're going to build the underlay. We're going to configure the OSPF, the Open Shortest Path First Routing Protocol. I'm first going to do this on the spine devices, and I'm going to do spine 1 and then spine 2, or vice versa, it doesn't matter. The reason why I'm going to do that and not jump from spine to leaf to spine to leaf is I could take the same configuration, so if we configure spine 1 first, I can then copy that over onto spine 2. Because if you look at it, they've got exactly the same interfaces. They've got the GIGI 001 to leaf 1, the GIGI 002 to leaf 2, and the GIGI 003 to leaf 3. So GIGI 001, GIGI 002, and GIGI 003. And of course, we cannot forget to include that loopback interface as well. And this is all going to be in the same area. And likewise for the leaf devices, they have got the same interfaces: GIGI 001, GIGI 002, GIGI 01, 02, 01, and 02 here. And again, they're going to have their loopback interfaces all in area 0. So this is going to allow you to get this network, this underlay, up and running quicker than just typing it in manually all the time. And then at the end, we'll do a quick ping from those loopback addressing to make sure those loopbacks can reach each other. And that's important because we want the next step, the overlay, to build the neighborship based on those loopback interfaces. So let's start off on spine 1. Let's go into edit protocols OSPF, and let's set area 0 interface GIGI 001.0, and I'm going to do 2.0, 3.0, and we cannot forget that loopback 0 interface as well. And if you're just wondering, I've already configured these interfaces. So if I just do top edit interfaces loopback 0, well, actually it's not do edit, it's do top show interfaces loopback 0.0. And you can see the IP address is already configured there. Likewise for the GIGI 001 interface, I've already configured the IP address in there. It's nothing you need to be aware of, but just know I've already configured those interfaces in the background. Right, let's do a quick show of the OSPF protocol, and that's it. I have got my area 0 with those 3 interfaces and that loopback. But what I've just done here is I've just done a quick show this pipe display set, and that's actually allowed me, it's allowed Junos to say those set commands, basically everything I've just done. So now I could just highlight all of this, do a Control V if I remember correctly. That's copy, I might be wrong there. But let's go into spine 2, and if I just go into there, so it's actually worked. So you can now see it's done the set protocols OSPF area 0 interface GIGI 001, 002, 003, and that loopback interface as well. So now if I just do show protocols OSPF, you can see that configuration has immediately been copied over. Great, fine. I'm now going to commit this with a comment of OSPF, and I'm going to do the same on spine 1. I didn't do that on spine 1. Commit with the comment OSPF. And now we need to do the same on the leaf devices. So let's just go into edit protocols. Again, I only need to do this once. So I'm just going to do it on leaf 1 and copy this over onto leaf 2 and leaf 3. So let's go edit protocols OSPF. Set area 0 interface GIGI 000 or GIGI 001. Really, nearly made a mistake there. But GIGI 001 to spine 1, GIGI 002 to spine 2, and let's not forget the loopback 0 interface. Let's do a quick show. It's all there, it looks good to me. And let's do that show pipe display set, and I can now just copy this, Control V, it is Control V, but first it's just commit this with a comment OSPF. Let's go on to leaf 2, let's just paste that over, and let's commit this with the comment of OSPF, and let's go on to leaf 3, paste all of that in, commit this with the comment of OSPF, spell it right. Now if I come back to leaf 1 and just do a show, you could see that the commands are there. Let's do the same on leaf 2. Let's do the same on the protocols OSPF. There we go, looks good. And let's do show protocols OSPF on leaf 3. Looks great. Now what I need to do now is just test, can the loopback interfaces ping each other? Quick validation. So let's just do a run ping from the source loopback address. So I'm on leaf 3, which has the IP address, the loopback 0 IP address of 200.10.20.5, and it's going to the destination of 200.10.20.1, which is spine 1. I think I've entered in that command correctly. Let's see. And there you go. You can see the loopback 0 interface on leaf 3 can ping spine 1. Can it ping spine 2? So let's just do to the 200.10.20.2, which is spine 2. And it's got connectivity. And it's just quickly make sure we've got the same on leaf 1. So it's ping from the source 200.10.20.3, which is leaf 1's loopback address, and then I'm going to go to 200.10.20.1 to spine 1. Got connectivity. 20.2 to spine 2. We've got connectivity. And finally, leaf 2. Let's do run ping from the source 200.10.20.4 going to 200.10.20.1. You have connectivity to spine 1 from leaf 2 and to spine 2 from leaf 2. There we go. Second step done. Note I didn't include the interface all. It's a quick way of configuring OSPF, but more than likely it's going to lead to some kind of problems. So be explicit. Explicitly define what interfaces you want to participate in the underlay. And now let's move on to step 3. So step 3 is going to be a little bit more in terms of the commands because we're dealing with BGP. We need to define a type, we need to define the neighbor addresses, and we also need to configure the route reflectors on the spine devices. That's easy to do in Junos. You just need to have the cluster command. I had to think about it there, but you just need to include the cluster command in the Junos configuration. So let's go through this on spine 1. So I'm just going to hit up 1 and let's do edit BGP, and you can see there's absolutely nothing in here right now. So first let's do set group. I'm just going to call this the overlay, and this is going to be type internal for iBGP, and our local address is going to use our loopback 0 address, so 200.10.20.1, and I need to build the adjacency to leaf 1, leaf 2 and leaf 3, not to spine 2. But I'm just going to enter it in there. Let's do a quick show, and you can see it's already starting to build it out. So let's do set group overlay neighbor 200.10.20.3, which is leaf 1, 20.4, which is leaf 2, and 20.5, which is leaf 3. Let's do a quick show again, and now you can see it's getting more popular. It's getting more built out. Now there's one command that you must not forget here. This is the multipath command. This allows, in this case, and we need to do this on the leaf devices, not on the spine devices, but this allows the leaf devices to use all available paths, all available interfaces that are going to that same destination. So if you look at host 1 here, if it wanted to send packets, whatever those packets are, to host 3, which is connected to leaf 2, it knows it could do so via spine 1 or via spine 2 because they've got the interfaces that go down to leaf 2 there. Multipath. We don't need to configure multipath multiple AS. That's if you're using eBGP as the overlay, i.e. you've got multiple autonomous systems. We don't have that. We just need to use multipath. But coming back to spine 1, we do need to enter in the cluster ID. So I'm just going to hit enter in here, and you can see it's asking for the cluster identifier. Now I'm just going to enter this in to be the router, the same as the router ID, just so we know what cluster is reflecting those advertisements and those data packets when this goes live. So for me, it's just more sense. So I'm just going to say set cluster 1.1.1.1, which is the router ID for spine 1. Let's do a quick show, and you can see everything is now configured. So we've got our type internal. We're using our local loopback address, loopback 0, which has this IP address, and we're building neighborship to 200, well, to leaf 1, to leaf 2, to leaf 3. And we've then got our router reflector command just here. Now, if I enter in that show, display set again, we can take almost the same commands and configure that, paste that, copy that over onto spine 2. The ones I can't copy over are the cluster commands and the local address. The type internal, unfortunately, is at the top here. So what I'm going to do is I'm just going to take these neighbor commands and just hit copy on that. But for now, let's commit this with the comment BGP. And that succeeded. Don't worry about this BGP license. I don't know why I get that, but yeah, it's a free software. And now on spine 2, if I just hit enter, I've now just created the group, BGP group overlay with the 3 neighbors. Now let's just move into that overlay. Let's do a quick show, and you can see those neighbor commands have just been copied over. So it just speeds things up a little bit. But I do need to define the type to be internal and the local address to be 200.10.20.2. And can I fit in the cluster command? I can. That is brilliant. 1.1.1.2. And now if I do a show on this, that's everything there. So let's do commit on this. I keep doing that. I don't know why. The apostrophe comes after the comment. I don't know why I keep doing it before. So commit with the comment. It's going to give me the warning, but it's going to succeed. That's spine 1 and spine 2 configured to have the overlay. But of course, at this point, it's not going to be established because the leaves haven't been configured. At that point now, let's move on to leaf 1. You just go up 1 and into BGP. Let's create the group. Call it the same for consistency overlay. Say the type is internal using the local address of 200.10.20.3, and we want to go to neighbor 200.10.20.1 and .2, and let's do a quick show on this, and that's all the commands minus 1 that we need on the leaf devices. Now remember that multipath command, we need that. So let's do set multipath and let's do show, and we can now see that's been configured right there. So in short, we've got type internal using our local loopback 0 address, multipath function to use all available interfaces to go to the same destination, and we have the neighbor adjacency, or we will have, to spine 1 and to spine 2. But now let's just commit this with the comment BGP, and let's do show pipe display set, and let's just take as much of the commands as I can do. So let's take these 3 commands from multipath down. My mouse is playing up. Control V, and let's go on to leaf 2, paste it in there, and let's do edit protocols BGP group overlay. Let's do show, and there they are there. Those commands of multipath and those 2 neighbor connections, those 2 neighbor configs. But we still need to define set type internal, local address 200.10.20.4, and let's do show. Let's make sure I'm happy. Yep, we've got type internal, local address, multipath, and spine 1, spine 2 neighbor commands. That's great. So let's commit this with the comment BGP once again. And guess what? Leaf 3 is going to be no different. So let's come onto leaf 3. Let's just copy those in. Edit protocols BGP group overlay. Let's do show. Commands are there. Set type internal, local address 200.10.20.5. Let's do show. Yep, looks good to me. Let's now commit that with the comment BGP. And now what we should have are the BGP adjacencies, the neighborships established. Let's go just onto leaf 1 because that's had this configured the longest in terms of the leaf devices. And let's do run show BGP summary. And there you go, right here you can see to spine 1 and to spine 2 they have been established. Let's do the same on leaf 2. So let's do run show BGP summary, and they have also been established to spine 1 and spine 2, And lastly, leaf 3, run show BGP summary, and they have also been established. That is the third step, configuring the overlay. But part 3 isn't fully done yet. There's one more command that we've got to do on the leaves and the spines that's really going to enable the EVPN. And that is inside the BGP group itself. So I've just gone on back onto spine 1, and let's go into edit protocols BGP group overlay. Let's do a quick show, and we can see all of the configs we've just been doing. Now the command that you do have to include if you want to do EVPN signaling is set family EVPN signaling. That's it. And if I do that now, we can now see that's been included here. The reason why you need to include this is because it allows BGP to say it's okay to use EVPN. It's okay to signal EVPN packets. It's okay to use this family EVPN to signal, to transmit and receive all of those different EVPN route types, those route types 1s, those route type 2s, etc, etc. So if you don't include that here, then obviously when we start wanting to build the EVPN protocol in a later step, it's not going to work because we've not enabled it in iBGP. So let's now do a commit with the comment updated BGP. Try that again with an underscore, and it's giving me the same error message. That's fine. So we have to do that on the spine 1 and on spine 2. So let's just do set family EVPN signaling. Let's commit this with the comment updated underscore BGP, and it's going to leaf 1. Let's do set protocols BGP group overlay family, not INET, nearly, EVPN signaling. Let's commit this with the comment updated underscore BGP, and on leaf 2 set protocols BGP group overlay family EVPN signaling, and let's update that with that comment. And finally leaf 3 set protocols BGP group overlay family EVPN signaling, and commit with the comment updated BGP. There we go. That is step 3 fully done. We've built the iBGP, we've built the overlay, and we've now said it's okay to transmit and receive those EVPN NLRIs, those network reliability reachability information for those prefixes. And here we go with the fourth step, configuring those VLANs, configuring those VNIs, and mapping those VLANs to those virtual network identifiers, those VNIs. This step is incredibly straightforward, but it's going to be a bit repetitive because it needs to be done on the 3 leaves. So on leaf 1, leaf 2, and leaf 3. Why are we not doing this on the spines? Because remember, we've got layer 3 here, and VLANs is layer 2. So the spines don't really care about the VLANs at this point. They're route reflectors. They're reflecting those packets. They're reflecting all those prefixes that are being advertised in EVPN, all those different route types basically. So when we create VLAN 10 and VLAN 20, we're going to do so on leaf 1, leaf 2, and on leaf 3. And when we create those VLANs, we also need to map them to the VNI, the VXLAN Virtual Network Identifier. And I kid you not, this is incredibly straightforward. It really is, and I'm not just saying that. When we've then mapped them, what we also need to do is create the layer 2 interfaces that are coming down to all these different hosts, these different terminals. And that's important because obviously these guys, they want connectivity into the network. And if that interface, whatever it is, hasn't been configured to have that tag, to have that VLAN, and to be an access interface, that traffic's not going anywhere. So enough said, let's go on to the CLI and actually start doing this. And here we go, here is leaf 1. Now, where do you configure the VLANs? It's in edit VLANs, funnily enough. And let's do set VLAN 10 because leaf 1 has VLAN 10. This is just the name though, so set V10, V10 being the name. And now we need to say the VLAN ID is 10. Now we need to map it to a VXLAN. And if I hit question mark here, you can see there's quite a few points, but it's really the last point, VNI, that we want to enter in. So VNI 5010, that's it. We have literally just created the VLAN and then mapped that to a VXLAN virtual network identifier. But if I hit up, there is also one more command that we do need to do. If I hit question mark again, it's ingress node replication. This is for multicast traffic. It allows the underlay, that leaf device, leaf 1 in this case, to make a copy of all that multicast traffic, that bump traffic, and send that to all interested parties on the underlay. So we need to enable that. So if I do a quick show on the VLANs, and you're going to see a few errors here, but don't be concerned, because this is correct. It's basically saying, hang on, you want to use VXLANs, but you've not configured a VTEP source. You've not configured a remote VTEP list or some kind of encapsulation, i.e. EVPN. We're going to do that in later steps. So for now, I can't commit to this configuration, but that's correct. So don't worry when you see this if you do it yourself. But you can see here we've got the name V10 with the VLAN ID of 10, mapping to a VXLAN with a VNI of 5010 with ingress node replication. But I also said that we need to create the interface that connects to host 1. And that is, let's go to the top, let's do set interfaces gigi 000.0 family Ethernet switching, interface mode, access, hit up, and now let's assign VLAN members V10 to it. That's it, that is leaf 1 done. Now let's go on to leaf 2 and let's do exactly the same. So I'm just going to do it right from the top. So set VLANs V10, VLAN ID 10, that's been mapped to VXLAN VNI 5010, and let's hit up and let's then do ingress node replication. But we also need to do the same for VLAN 20 because leaf 2 has VLAN 20 as well. So let's do set VLANs V20, VLAN ID of 20, and that's mapped to VXLAN VNI 5020. Let's hit up with ingress node replication. And just like we did on leaf 1, we now need to configure those interfaces. So host 2 is connecting to the gigi 000 interface. And let's do family Ethernet switching, layer 2, interface mode, access. Let's hit up and we're going to configure this to have the VLAN member of V10. And we now need to do the same for gigi 003, which is connecting to host 3, family Ethernet switching, interface mode, access, VLAN members V20, and that is leaf 2 configured. Finally, on leaf 3, we only need V20, VLAN 20, so you just do set VLANs V20, that's the name again, VLAN ID of 20, being mapped to VXLAN VNI 5020. Let's hit up, set it to have ingress node replication for all that bum traffic, and now let's configure that interface, gigi 000, family Ethernet switching, interface mode, access, with VLAN members V20. And that's it. That is step 4 done. We've now created the VLANs associated, mapped them to VNI, and configured those VLANs to use ingress node replication. That's really the only type of bum handling sorry, that made me tickle. That is 2 words that really shouldn't go together in networking. But anyway, let's move on. But ingress node replication is the Junos way of handling that broadcast, unknown unicast, and multicast traffic. And then we created those interfaces and assigned that VLAN as an access interface to those interfaces to those connected hosts. Quick, easy, step 4, done. And now let's move on to step 5, where we are going to configure that distributed or Anycast gateway. Now the question is where are we actually going to configure that? So are we going to configure that layer 3 interface on the spine devices, or are we going to configure it on the leaf devices? The honest answer is you could do either or. You can do so on the spine devices or you could do so on the leaf devices. If you configure it on the core devices, that's what's known as a central routing and bridging architect. if you do it on the leaf devices, which are connecting directly to the end devices, that's called an ERB, or edge routed or routing and bridging architecture. And there are pros and cons, as I've said before, to either. So usually with our CRB model is when you've got more north to south traffic, whereas if you've got an ERB model, that's more if you've got east to west or west to east type of traffic. Personally, I always gear more towards ERB. Generally, I prefer that more because it stops what you get with CRB called hairpinning or tromboning, where if you've got, in Leaf 2's perspective, if you've got a CRB model and host 2 wants to communicate to host 3, if it goes through spine 1, Leaf 2 would send that traffic up to spine 2, where the IRB interface is located, only for spine 2 to send it all the way back down again. It's called hairpinning, tromboning. So for me, it's just logical to have the IRBs at the leaf layer, at the edge layer. But it does depend on, obviously, end user requirements and the type of traffic that they've got going over their network. But let's bring it back to this configuration. So we are going to be configuring these IRB, these integrated routing and bridging interfaces on Leaf 1, on Leaf 2, and on Leaf 3. And of course, as I was just saying, that is going to be an ERB model or ERB architecture. Now, the IRB is a layer 3 interface, of course, and within that, we are going to define a particular INET or Internet IP address. And we need to then configure that to be part of those VLANs. And you'll see the configuration to do so is very straightforward. And this is important because when host 1, using this example, wants to communicate to host 3, they're in different subnets and they need that gateway, and the IRB serves as that gateway to allow that inter-VLAN routing. But because we've mapped in the previous step those VLANs to a particular VNI, it also then allows inter-VNI routing as well as inter-VLAN routing, because don't forget, over here we've got these tunnels where all those packets are going over to go from one leaf to another leaf, and maybe from one broadcast domain into another broadcast domain. And as I've said previously, host 1 here, it could be a server, couldn't it? It could be hosting multiple virtual machines. And by having this Anycast distributed gateway, it allows scalability, it allows flexibility. Because in the data center and in some campus environments where you've got virtual machines, they can migrate those virtual machines from one server over onto another server here. So let's say host 2 was a server as well. And thus that virtual machine has just migrated over. By having that IRB interface with that same virtual IP and maybe that same virtual MAC address, allows this host to migrate over to this host from this server's virtual machine to migrate over to this server. It allows it to have connectivity regardless of wherever it roams to, essentially, wherever it migrates to. But how do you configure this? It is very straightforward, so let's jump on the secure CRT and start configuring this. So let's configure this on Leaf 1 first. So let's do set interfaces IRB dot or unit 10. I'm doing 10 because we've got VLAN 10. If it was VLAN 500, I'd be doing IRB.500. You get the point. It allows consistency and it's just helping troubleshooting if the needs actually arise. And now we just need to give it the address. So let's just say, and you can actually see I've already defined the physical IP address and the virtual IP, the Anycast gateway address at the top. So we're going to give it the address of 192.168.10.1/24. And now I can do the virtual gateway address. This is the distributed gateway. That's that Anycast gateway that we now need to configure. 192.168.10.254. And if I do show interfaces IRB.10, we can now see it's got the address. It's not a physical address, but let's just call it the physical address. But we are going to be using this virtual gateway address to be configured on Leaf 1 and on Leaf 2. Now you can configure And I was just having some trouble finding the command, but under set interfaces IRB.10, so within the unit itself, if I hit question mark, and right at the bottom, you can see here we can configure the virtual gateway v4 MAC, and that is what we're going to do. So let's do not v5, v4 MAC, and let's give it a MAC address starting with 00, and let's just do 01, 02, AA, BB, CC. And now if I do show interfaces IRB.10, you can now see we've configured the IRB interface to have this physical IP address, this physical INET address under family INET, but it's then got this virtual gateway address. That's that Anycast gateway that's going to be shared between Leaf 1 and Leaf 2. They're going to have this same IP address, and they're also going to have this same virtual v4 MAC address. You can let the system create its own MAC address, and it's going to be the same MAC address that's used in VRRP, but it's generally recommended that you configure your own. So that's why I've done it here. So we've created the IRB interface. What's next? We now need to assign that IRB interface to that VLAN. And to do so, we just do set VLANs v10 layer 3 interface IRB10, and let's just do a quick show on that. And you can now see VLAN 10 with this ID of 10 has this layer 3 interface, using ingress node replication, and is associated or mapped to VNI 5010. Leaf 1 done. Leaf 2 is going to be a bit longer because we've got two IRB interfaces, because there's VLAN 10 and VLAN 20. So we need IRB.10 and IRB.20 respectively. So you just do set interfaces IRB.10, family INET address 192.168, and don't forget this is the physical IP address 10.1/24, virtual gateway address, Anycast gateway address of 192.168.10.254. Let's hit up, and I'm just going to go back to Leaf 1 and copy that MAC address. So let's just copy it here just so I don't get any errors, and let's paste that in here. But first let's do virtual gateway v4 MAC, paste, and let's make sure I'm happy with that. Show interfaces IRB.10, and that's it, done. Now we need to do the same for IRB.20, family INET address 192.168.20.1/24 with the virtual gateway address. Again, this is a .20 because this is for VLAN 20. Anycast gateway is 192.168.20.254. Let's hit up. Go back to the unit itself. IRB.20 unit 20, and it's going to have the virtual gateway v4 MAC address, and I'm going to create it now. So let's just do 00. It obviously needs to be different, so I'm going to do 02, 03, and let's do DDEEFF, just to make it different from the virtual v4 MAC address that's used for IRB10. And let's do show interfaces IRB. Now we've got our IRB interface for unit 10 and unit 20, and they're both using their different IP addresses for the physical interfaces, but really the virtual gateway addresses are there. They're configured differently with different virtual MAC addresses as well. And whilst I'm here, I'm going to copy this because we need to do the same on Leaf 3. But first, let's do set VLANs v10 layer 3 interface IRB.10 and set VLANs v20 layer 3 interface IRB.20. Leaf 2 is done. Now we move on to Leaf 3 where there's only VLAN 20. So let's do set interfaces IRB.20 family INET address 192.168.20.1/24 virtual gateway address 192.168.20.254, and it's hit up and go back to the unit. And now it's define the virtual gateway v4 MAC address, hit paste, there we go. And now let's do show interfaces IRB.20, looks good to me. And it's now assigned the VLAN 20 to have that layer interface of IRB.20. Done. We've now just configured our layer 3 interfaces on Leaf 1 for VLAN 10, on Leaf 2 for VLAN 10 and VLAN 20, and on Leaf 3 for VLAN 20. Very straightforward, quick, easy, relatively speaking. And here we go. Here's the sixth step. Now we start to configure EVPN. And for me, it's kind of backwards because you'd think this would be the biggest step. This is, in my opinion, one of the smallest steps because we've configured the routing options. We've configured the underlay, configured the overlay, built the VLANs, associated them to a VXLAN VNI, and then configured the distributed or Anycast gateways and associated or configured them to be part of those VLAN interfaces, those VLAN tags. So EVPN at this point doesn't need a lot of configuration. You'll see what I mean. So if I go into edit protocols EVPN and do set, you could see, yes, absolutely, there is a lot of configuration that we can actually do here. However, all that we need to do at this point is actually say, what is the encapsulation? Now, if you think about EVPN, what does that stand for? Ethernet Virtual Private Network. It's a VPN, it's a layer 2 VPN, and with any VPN technology, it likes to deal with tunnels. But here we're saying, well, we want to encapsulate our layer 2 VPN information, all of those NLRIs, all those EVPN route types in a particular data plane technology, and that is going to be VXLAN. So we've just now configured, hey, Mr. EVPN, use VXLAN. Yes, you're a control plane, but yes, use the data plane. It's used as VXLAN tunnels to exchange all of this reachability information. The other thing that we also need to do is define the extended VNI list. This is defining for EVPN. What VNIs do you want to advertise? So if you've got 10,000 VNIs, yeah, you could do that here, or you could just do all. So I want to advertise all of my VNIs with EVPN. Or because we've only got 2 here, well, I can enter in, open up a bracket and do 5010 and 5020, close it off, and let's do show. And you can now see we're saying, yep, the encapsulation is VXLAN, and we are going to be advertising this list of VNIs 5010 and 5020. The other command we do need to do as well is set multicast mode, hit question mark, and there is only ingress replication. It's what we've done for the VLAN, but now we're doing it for EVPN, and that is it. We have just configured EVPN on leaf 1. Now if I do a show pipe display set, we can see all of those configurations I just done. So I'm just going to copy this because we can use this on leaf 2. So I'm just going to paste that in there, and on leaf 3, paste that in there. Done. That was quite literally step 6, configuring EVPN. And in summary, we've defined the protocol EVPN to use VXLAN to tunnel all of the reachability, all of that signaling information that EVPN can actually do. We've told EVPN, we've configured EVPN to use, Juniper only supports this at the time of doing this video, but to use ingress replication, so all that bump traffic is copied. It's replicated by that leaf, by leaf 1 in this case, and sent to all interested parties, which would be advertised and known by the route type 4. And we've then said for the EVPN, the extended VNI list is 5010 and 5020. I just want to check that actually. That might look a bit suspicious to me. So let's do show protocols EVPN. Yeah, that's okay. It was just a bit weird there because we could see it's in the brackets, but if you come up here, we've got 5010 and 5020. But that's fine. But that is configuring EVPN. Let's now move on to step 7. And here we go. Here's the 7th step, the final step in configuring. Now we're going to configure the VXLAN, the Virtual Extensible Local Area Network. And this is important because we've configured everything else so far with the VLANs, the VNIs, the layer 3 interfaces, EVPN, the routing options. We've done a lot. But now we need to let the leaf devices know it's okay to build those VXLAN tunnels to and from each other. And let me just draw that again because my glorious pen tool just was automatically erasing them. But you get the idea, is that we need to tell leaf 1, leaf 2 and leaf 3 it's okay to build these tunnels which will be identified by that VNI. So we'd have a VNI for this one, and a VNI for this one, and a VNI for this one, i5010 or 5020. And at that point, the leaf devices become those VTEPs. They become a virtual tunnel endpoint. And the same for leaf 3. And a virtual tunnel endpoint is all about encapsulating and de-encapsulating that header information. It's about taking that layer 2 header, those layer 2 frames, maybe stripping off the VLANs, adding in that VXLAN header, and then an outer UDP and IDP and IP header information. Tongue twister there, I know. But the leaf devices become those VTEPs where they're adding in that header information, and at the other end stripping it all off, and out comes that layer 2 header. And thus, with VXLAN, you can, in data centers and campus networks, transport layer 2 frames over this layer 3 network. But we need to let the leaf devices know, hey, it's okay to use VXLAN. It's okay to tunnel traffic, and that's why we need to configure VXLAN with just a few configurations. Honestly, there's not much to it. So on leaf 1, let's go into top, and we now need to go into edit switch options. We've not gone into the protocol VXLAN itself. It's within the switch options. And we need to define here what is the source, or the VTEP source, nearly forgot it there, interface. And you hit question mark here and you can see all the interfaces that have been configured. And as we've done previously, it's the loopback 0, unit 0, or dot 0 interface. That's what we've used to build the overlay, the IBGP peering. So we're going to use loopback 0.0. And something else that is absolutely needed is this route distinguisher here. This allows the device to identify itself. It allows it to distinguish itself from all the other leaves or spines, depending on your model, in the network. And you can either have a type 0 or a type 1 route distinguisher. It's just how you define it. I like the type 1 because you're defining the router ID followed by some arbitrary value. So if I do route distinguisher, I'm going to use leaf 3's route distinguisher of, or router ID of 1.1.1.3, and then colon, and I'm just going to use 65100, which is the autonomous system number for this whole EVI, for this whole EVPN virtual instance. And if I do show, you can now see we've said, hey, VTEP, it's okay to use a loopback 0, and this is your route distinguisher. But we also need to define a route target. Now that's not under route target, it's actually under VRF target itself. And if I hit question mark, you can see you can import and export particular policy statements if you want to add a community value and do something with it. So pretty complex. Or you can add the community in here. Now what I want to do is do things a little bit more differently, because on leaf 2 there are two different VNIs. There's essentially two different VRFs, virtual routing and forwarding tables. And if we were to configure the VRF target in the switching options, it creates this global VRF target, which is fine. But I want to distinguish them. I want to separate them out. And this then just becomes global. You can't configure a VRF target for 5010, VNI 5010, and a VRF target for VNI 5020 within the switching options. So what I'm going to do, so I'm going to do things a little bit differently, and hopefully this works, fingers crossed, is if I go back into top protocols, EVPN, and I'm going to define here the VNI options, so the virtual network identifier, the VXLAN VNI options for VNI 5010. Your VRF target, so I'm doing it specifically now, is, and I'm going to do target. You have to write this out in Junos in this way. So target 65100 followed by 5010 for the VNI 5010. Let's do show, and you can see that it's already now just being configured. And it's already saying that you must have a global VRF target as well. So I'll come back to that. But if I just hit up twice, let's do the same for 5020, 5020, let's do show, and it's still giving the same error message, but you could see the VNI 5010, 5020, we've now got these independent and separate VRF targets. Now let's just get rid of that error message. So let's go top and set switching options, VRF target, and I'm just going to create a global VRF target of 65100. I'm just going to give it a random number of 65100 for the ASN :100, just completely random. And now if I do a commit check, and note now that all those error messages have disappeared. So I've done a commit check and no error messages are now appearing, which is great news. So I'm going to commit this configuration with the comment of done. I'm just going to have some fun now. So that is leaf 1 actually done. Let's go on to leaf 2. And let's do the same under here. So we need to go into edit switch options. And let's set our root distinguisher to be 1.1.1.4 for leaf 2 within ASN 65100. We also need to define our global, as I've just learned, our global VRF target. And again, we need to write target 65100 100. Again, it's just that random number. But again, I want to be specific, so I'm going to go into the top, edit protocols EVPN, and I'm going to define the set VNI options for VNI 5010 to have the VRF target 65100. Don't have the space there, nearly caught me out. 65100 5010. It's giving me a syntax error, so let's see what I'm doing wrong. So I want VRF target 65100 5010. Yeah, I'm not too sure what I've done wrong there. I missed out the target, so there we go. That's why I didn't accept it. But let's hit back up and let's do the same for 5020. Let's go to the top and do a commit check. And I missed out the VTEP source interface under the switch options, so that's why we always do this. Set switch options. VTEP source is going to be our loopback 0. And let's do the same again, commit check. And all those error messages are gone. So let's do commit with that comment, done. And finally, let's go on to leaf 3. And let's just do set switch options before I forget. Let's do the VTEP source interface of loopback 0.0. We also want to do our root distinguisher, and this is leaf 3, so 1.1.1.5 within ASN 65100. I want to set my global VRF target 65100, and that random number once again, and it's going to edit protocols EVPN, and let's set the VNI options for VNI 5020 to have that VRF target 65100 5020, and you can see that's now being configured there. So let's do a quick commit check, and there we go, it has now succeeded as well. So let's do a commit comment done, and that is the final step. That's step 7 done, configuring the VXLAN. So let's recap. Under switch options, you need to configure the VTEP source. Almost forgot that myself. You need to configure the root distinguisher and that global VRF target. But what I did additionally is I went into EVPN, the protocols EVPN, and I configured specifically for that EVPN what that VRF target is for that VXLAN VNI, which was very important on leaf 2 because leaf 2 has got multiple VNIs. If you've just got one VNI, I didn't really need to do that. But again, just to show you a bit of flavor, a bit of something different that you can do in Junos. And here we are. Here's the 8th step, the final step. I did tell you, I did warn you to have some coffee. I know I've needed some. But the last step, validation. So everything is configured. So I've just refreshed the config, the secure CRT, the terminal on leaf 1. But first, let's just do, from a leaf perspective, let's just do a quick show root. And this is the default routing table, inet.0, and we've got all our routes in here. But if I keep hitting the spacebar, look at this, we've now got our BGP EVPN.0. That is the default routing table for all BGP routes which have been learned through or from EVPN. So think of it as the rib in for BGP for EVPN. It's that routing integrated bridging table in. It's that in table for BGP. And here we can see our type 1 routes. So these would be any ESIs, but as you can see, none of the hosts are actually multi-home. So they're just really coming out with no real values here. But if I keep scrolling down, we've then got our type 2s and more type 2s, more type 2s. Then we've got some type 3s, etc. Just look at all of this information. But if we go into it a little bit more, we can see here is the route distinguisher. So this is coming from leaf 2 because this is 1.1.1.4, which is the route ID of leaf 2 within 65100, and it is for the VNI 5020. Here is the MAC address and maybe an IP address, and if I want to get to this particular MAC address, I can do so via spine 1 or via spine 2, and I've got multi-paths to get to that destination as well via this interface here or this interface there. So lots of information, but what you can also do, if I just do a quick show interface VTEP, hit question mark, let's just do brief, you can see all the VTEPs, and actually let's do terse. You can see all the VTEP tunnels that have been automatically created. So the VNIs and the VTEPs are separate. The VNIs are identifying that virtual network instance, whereas the VTEP are identifying those VTEP points, those tunnel source and destination endpoints. But let's actually do a quick verification, because we can see the routing tables are populated. We can see that there's entries there. Let's do the verification on host 1. So let's do a quick verification test. So I've just brought up the terminal for host 1, and I want to test initially, can host 1 ping host 2? Can we ping a server, a tenant, a destination that is in the same VNI as us? So let's do ping 192.168.10.12, and we've got that connectivity, round trip connectivity. So we've just qualified intra VNI routing works. But how about inter VNI routing? So let's now ping host 3 connected to leaf 2. So it's ping 192.168.20.13. So this is testing the inter VNI routing, and there you go. That's all it is, everyone. Those are the 8 steps to configuring an EVPN VXLAN domain. And there we go, everybody. That is the end of this session. That is the end of this part, this video on the EVPN VXLAN series, where we've gone into quite a bit of detail into how to configure EVPN and VXLAN using the 8 steps to get that actually operational. And there's a lot of information, but just follow it step by step. Step 1, configure the routing options. Step 2, configure the underlay. You need that for step 3, where you configure the overlay, iBGP or eBGP. Step 4, as I did, configure the VLANs. Map them to a VNI. And don't forget the ingress node replication. Step 5, where we created the distributed or Anycast gateway. That's basically just creating an IRB interface with a physical IP address and a virtual gateway address, which is going to be shared and distributed amongst, as we did, different leaves. And we then configure that as that layer 3 interface in that VLAN. And if you have tenants which are in different VNIs, as we have 5010 and 5020, you need the IRB interface, IRB.10 and IRB.20 on each one of those leaves to allow that connectivity. And then in step 6, we configured the EVPN. We configured the extended VNI list and the encapsulation to use VXLAN. Step 7, configured VXLAN, where we just said what was the VTEP source interface, that loop back 0, and what was our route distinguisher, and what were our route targets. You absolutely need them. And finally, the validation, end-to-end intra and inter VNI connectivity test just succeeded. So again, hope you found that useful and informative. If you like this video, please give me the thumbs up. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. Other than that, thanks for watching and goodbye.